So the first thing I'm just going to go over is our project setup. There are a few packages that you need if you want to use the Unity's entity component system with jobs, with rendering. I'm going to go over those, just what you need to install if you're using my project. If you're using my project, this is already included. You don't have to go do this. If you're not using my project, then you will need to do this. Obviously, the first thing you need to make sure you're using is to show preview packages. We're using several preview packages in this tutorial. Hopefully, those packages will not be preview for too much longer. They should get released sometime here in 2020, and then we'll be okay. You can search for those packages using the search bar up here as I show them to you that I already have in my project that you will need. There's really only 3 projects you need to install, or packages you need to install. Those packages will install all the other components and you'll be okay. The first and the biggest one that you need is the entities package. This is the majority of what we're going to be using today. This comes along with a lot of other packages that we'll also be using, but make sure you grab the entities package. This will give us mathematics, which we'll be using a lot of. This grabs the job system, which we'll use as well today. You get the burst compiler with it. It comes with a lot of data that we need, a lot of other packages. So make sure you get this entities package. The other one that you will need to make sure you grab is the dots editor. The dots editor just makes it a little easier to use the dot system, aka entities and jobs, inside the Unity editor. So make sure you grab the dots editor. And then last, but definitely not least, is the hybrid renderer. For us to be able to do a pure entity component system game, you have to use the hybrid renderer. This allows us to render entities in the system, and it just makes the system a lot simpler to use. You don't have to do a pure ECS video game. You can use hybrid. I know this is hybrid render, but you can use a hybrid model approach. I will explain what that is momentarily. So, but for the tutorial I'm doing today, it is a pure ECS game, which means we need the hybrid renderer for that to work. So that's it from a package manager perspective. Once you have those packages, you should be ready to go. So let's actually take a little look at what entities are. So I'm going to pull up the documentation for entities, just so we can understand because what does ECS mean? What is an entity component system? How does that differ from mono behaviors in a normal Unity world? So in a normal Unity world, you would create game objects, and on those game objects, you would add mono behaviors. And depending on how you're structuring your video game, maybe those mono behaviors are big monolithic systems, or maybe they're very small independent items, and that's okay. For instance, maybe you have a mono behavior that is like a fire rocket mono behavior, right? And that mono behavior essentially has an update method, and it's listening for player input for the fire command. And if it gets that command, it spawns a rocket. It shoots it. It figures out what direction it should fire that rocket. It knows what speed it should fire that rocket at, and it spawns that rocket, and off it goes. Maybe that rocket was a prefab. It's its own game object that instantiated, and maybe that rocket has its own mono behaviors that can control some data. Maybe it doesn't. Maybe you're just using the physics system, and you're giving it a velocity, and you're giving it some physics properties for it knows how to move, right? That's how we would normally build up a video game, using mono behaviors. And everyone, if you've ever used Unity, that should be very natural and should be very simple to understand on how that works. The entity component system kind of flips everything upside down. It is, instead of it being an inheritance based programming model, it's more of a data orientated programming model. And what I mean by that is, instead of looking at things as an object hierarchy, instead of having a automobile base class, which could then become a car or a motorcycle or a boat, or something like that, right? From a vehicle down to a child type, where you inherit the functionality of the base and then you have to implement the specifics in your child. That's an inheritance model. That's standard object oriented programming. In a data-orientated programming model, things are very, very loosely coupled or very decoupled. It means there is really no inheritance. There is no vehicle that then can spawn a car or can spawn a motorcycle or can spawn a boat. Instead, you have what we call entities, components, and systems. And I will describe how you can build a car and a motorcycle using those systems. So essentially, an entity is really just a pointer. It is a thing. It does nothing on its own. It has no data. It doesn't know how fast it is. It doesn't know how strong it is. It doesn't know where it should go. It doesn't have data. It doesn't know anything. It's really just a pointer. It is a thing. It's a entity one or entity two. That is all an entity is. It's a lookup to other things. Components are data. So when I talked about a mono behavior, and you have this mono behavior that's I want to fire a rocket. Well, if I want to fire a rocket, I need to know what kind of rocket I should fire. Maybe there's several prefabs, right? So you have this mono behavior that has this functionality of knowing how to fire a rocket, but also needs to know what to fire. So it has the data for that, has that prefab information. Maybe it knows this rocket should be a speed of X, and this other rocket is twice as fast. So it has the data of the speed for the rocket. So mono behavior has logic and it has data combined, whereas in an entity component system, the components are just data. It is a structure of data and nothing else. There is no logic that lives on a component. It does nothing. It doesn't know how to do anything. But unlike just a thing, an entity that just knows its ID, a component can now have data. You can store speed or how strong it is or how long it should live or a direction it should go or any other data-esque item you can think about, right? That is what a component is. It is a self-contained isolation of just data. It is a structure of just data. It's floats and it's bools and it's can be string data or binary data, or whatever kind of data you need to store. But that's all it is. It has no logic. It doesn't know how to move. It just knows how far it should move or how fast it should move. And then that's where systems come into play. Systems are the logic that know how to take that data and transform it and execute. But a system has no data on its own, right? A system doesn't know how fast things are. It doesn't know how strong things are or where things should move. It needs to get that data from components. So a system is really just that logic. It's a very loosely coupled implementation. It has the logic that says, I need to move every frame. And in order to know where and how far to move, I need to go look up the components for an entity that say, here's my speed and here's my direction. Let me apply the logic that puts that together, right? That we multiply direction times speed. And then that basically allows us to then update our position. So that's what a system would do. It can change data. It can update data. It can inspect data and decide what it wants to do. And that's the system. So in that rocket example, there would be a system that says, oh, you want to fire a rocket because I have this data that says you are pressing the fire button. So it has the logic to spawn a new rocket. It has the logic that says, I want to take the data that says how fast this rocket should be and apply it to that rocket. It has what direction should it move. It can calculate the direction it should fire based off of, wherever the player is looking at, for instance. So that's what a system does. And then maybe there's a system for just moving the rocket. And this rocket, which is an entity, like we said, it's a thing. Maybe it has a component for speed. Maybe it has a component for direction. And each one of those components just has that. It has what its speed is, and it has what its direction is. But those components are isolated. They don't know about each other. They don't interact with each other on their own. And they have no logic. And then maybe there's a rocket movement system. And all that rocket movement system is saying, hey, for entities that have this movement and have this direction components, let me combine those in a system every frame of the game or every update of the game. And then let me update the rocket's position. So I want to move the rocket based off of its speed and based off of its direction. And I will do that every game update until there are no rockets that have those components. So that's it. That's really what an entity component system is. And I'm going to be going through that. I will be walking through what all that means in practical examples. We'll get into entities, we'll get into all the components, we'll get into systems. It will make more sense when you see it implemented and done. So don't worry about that. But that's just an overview of kind of what entities, components in systems are, just so everyone kind of has that same lexicon of what we're going to do.